Hello friends, so today we're gonna discuss AtCoder Beginner Contest 165. I will first discuss the first three questions in this video and then the subsequent videos will consist of the later questions. Okay. According to me, the first three questions are a little bit hard with respect to the first three questions of the other AtCoder Beginner Contest, but we will discuss them one by one. So the first question states that Takashi the Jumbo will practice golf. His objective is to get a carry distance that is a multiple of K, while he is only make a carry distance between A and B inclusive. So if he can obtain his objective, print OK. If not, print not good, NG. Okay. So the question really is that you have a value between A and B and you have to find out whether there exists a carry distance between A and D inclusive such that it is a multiple of K. So you can easily just iterate over the value of A and B. So you can take the input of K, A and B, and because they are very small, K, A, B, and then you can just iterate over them. For int A I equal to A, I less than equal to B, I plus plus, and if like just I modulus K is equal to 0, then we have found a number. So you have to print out OK and just return, else come out of this loop, print ng, and that's it. Let's try this out and read the second question. The second question states that Takashi has deposit of 100 yen, the currency of Japan, in the AtCoder bank, and the bank pays an annual interest rate of 1% compounded annually. Okay, a fraction of less than 1 yen is discarded. Just pop up first. It's giving OK, so let's submit it. We can be sure that this is not a hard problem. So the next question statement states that assuming that nothing other than the interest affects Takashi's balance, in how many years does the balance reaches X yen or above in the first time? Okay, so you have firstly deposited 100 yen and you want to find out the years after which it becomes more than X value. Okay, so the basic thing is if you deposit 100 rupees and the interest which you get is 1 upon 100 into the this value which is 100 and the final value will be 101. Then because you are compounding annually and the interest is compound interest, then this becomes the new principal and you use this and 1% and the value will become 102. I hope you understand the logic. It's a very simple logic, but you just have to store this value because for the next principal you have to know this value. And in the question itself they have given that X can become as large as 10 to the power 18, but there's an input also, very large input, and it just goes up to 3760, and so we can easily assume that the largest value can be up to this. So we can easily make an array of size 4000 and store every value at each year in that array. Okay, so the question in which what we can do is we can make a long array of size 4000 and we can initialize the start one with 100. Okay, then we input long k at which we want to reach, and then what we can do is we can do a for loop from I equal to 1 because we have initialized the first value with 0, and we can go up to 4000, and then what we can do is a of I is the previous value plus 1% interest into the previous value, which I've told you in the earlier concept, and then we will just have to check if a of I has become greater than or equal to k. So if this condition has reached, now this is the year on which we are iterating from 1 to 4000, and if we reach a certain year at which our value of AI exceeds the given value, So it means that we have reached that year. So we just have to print that year, cout I, and we can return out of this loop. And this will always terminate. So we don't have to like just come out of this loop, and that's the logic. Let's also run this and go to the third question. Okay, the third question is a little bit tricky to understand first, but the question statement states that, okay, you can run this, like run this on this large input, and it's giving the correct answer. Okay, so we can easily submit this. And the first one is also accepted. As you can see, this one is running. Okay. So the next question statement states that you are given positive integers n, m and q are the number of quadruples of integers ai, bi, ci and di. Consider sequence a satisfying the following condition. So you have to find a sequence a. So there's a sequence of a. In sequence a there are n positive integers. So this is n. So it means there are a sequence which have n positive integers, and the value of that sequence can go from 1 to m. Okay, that's also cool. So you have to find out first, you have to find out a sequence of length n, and each value of that sequence should be in the range from 1 to m. Okay, then let us define the score of this sequence as the following. So that sequence has a score in which the score is the sum of values of di over all indices I, such that a of bi minus a of ai is equal to ci, and if there is no such I, the score is 0. So it will be more clear with this example. So this is the n which is the length of the sequence. So this is the final sequence they have printed out, which you can use, and this is the length of n, and every integer is in the range from 1 to 4, as you can see, and there are 4 like q quadruples, and they have 4 values ai, bi, ci and di. So what you are saying that in that sequence of a, if you take out b as an index and use that, so if in that sequence a the bith index minus the aith index value, if that difference is equal to ci, then the score of that quadruple is equal to di. Okay, so as you can see in this, if this is the sequence, then if you choose ai and bi, so the first minus the third, 3 minus 1 is equal to 4 minus 1 equal to 3. So this is the difference, and if this condition holds true, then this is the score of that quadruple. So if we choose the sequence a to be this, and now we check this sequence for all of the queries, all the quadruples. So the first quadruple states that this quadruple holds true, because if we subtract the first indexed item from the third indexed item, the difference will be 3. So yeah, it's true. So we add this total score to the total value. This also holds true because the first minus second, 3 minus 1 equal to 2. Yes, true. So it's also added to the score. But if we subtract 2 minus 3, 4 minus 3 is equal to 1, and that is not true. So we don't add this to the score, and the final score will be 100 plus 10. Okay. So I hope you understand the question. So the question is simple, but you have to first find out a. But as the constraints are very small, the value of n just goes from 2 to 10. So it means you have to find out a series of length. So let's say there's a maximum case, there's a series of length 10. So as you can see, let's assume for 4. So in each there can be numbers from 1 to m, which is 1 to 10. So there are 10 cases to fill in this point, 10 cases to fill at this point, 10 cases to fill at this point, 10 cases to fill at this point. And also we don't have to, because we have to find out bi minus ai. So b, the index of later, should always be greater, because ci is always greater. Ci is always positive. There are no negative values. So it means that as we go down the series, the number should increase. So if this is 10, then we have So let's assume we have 10 values to fill here, 10 values to fill here. So if that also happens, we have to find out 10 to the power 4 cases. But that's the maximum. We don't have to find out that much cases, because as we go down the stream, the number of cases or the number of sequence values decreases. So what we can easily do is, we can, and the value of di is 10 to the power 5, we can make every possible sequence, because the constraints are very small. We can find out every possible sequence. So what I mean by that is, you can make this one, and then you can make everything 1, because it should be increasing. Or you can make it 2, and then 1 1 1, or 2 2 2, every possible sequence. And you want to find out whether this sequence, for this sequence, you can check for all the queries what is the maximum answer. So it's just a simple brute force, but you have to just first generate all the possible sequences, and then for each possible sequences you just have to find out what is the maximum score among all possible sequences in the set. So that's the approach we can use here. So let's write the code. So for generating every possible sequence, we can use like recursion to find out the possible sequences. So what we can do is, first we take the input, which is n. So we can make these global, which is better for this question. N, M, and Q, and we will make the entry of N, M, and Q. Then we will also, because it's value of A, B, and C, the queries can go up to 50 queries. They can be maximum of 50 quadruples. So we can make 50, an area of 50 for A, same for B, C, and D. Okay, then we have to find out the answer. We can initialize it to 0, and we have also made a vector to find out what is the sequence of A. So this is the vector which will store the sequence of A. What will be our A will be. Okay, so then we will iterate over a for loop for the Q quadruples and input it, Cn of AI, Bi, Ci, and Di, and then we will like do a DFS call. Like we can assume it to be a DFS because we are doing recursions, and then for simplicity what we can do is, because A and B are indices and they are giving in the form of from 1, so we can make them from 0, which will be simpler for us. So you can subtract 1 from them. Okay, then you will do your DFS. This is the, so you will see what these are, and then you will output answer. Okay. So now we have to make this DFS. So what this DFS will be, it will store I, which is actually the length of our V, or the A series we want to find out, because initially the length is 0. So we have first make the length equal to 0, which I have denoted by I, and then I also send out the current value, which is actually the value from which we want to start. So because we want series in which the first value can be 1, 2, 3, so we have to do a loop, but first value will find out what will be the next value will be. So we have to keep count of what the first value will be, so that we can find out the next value which will be smaller than the first value. I hope you understand, because if we do not know the first value, how will we find out the next value? We don't have to iterate over all the values. We cannot put every value here. Okay, so we have also find out send out 1 because the minimum value of m can be 1 and it can be up to m. Okay, so now what we will do is, if I, which is actually the length, if length is greater than or equal to n, which means like we have filled the value of v with n integers. So now we have filled the value, the vector with n integers. So we have to check at that point whether which is the maximum value of answer. So now we will iterate over the quadruples for int. So what you can do is, so you can write it here also, or you can just do answer is equal to max of answer, and you can also make another function check, which will check whether what is the maximum value of answer at this point, and you can check all the quadruples with this value. Okay, so we can also make this check function which will return an int value, and this check function, what will it will be do, it will, so we will make the score initialize for this condition at this vector point. So now we have filled our vector with n values, so we have to at this point check what is our score for this vector which we have just generated. So we will initialize our val to 0, we will iterate over the quadruples, and v of bi, so we have to find out if the bith index in v minus the aith index in v, and if its difference is equal to c or I, then val plus equal to d of I, which I've told you in the drawing board, and then we just have to return val. I hope you understand. So in this check function, we will iterate over all the quadruples and find out the value for this configuration of integers, and we will return the answer. And if that answer is maximum, then our global maximum which we have ever found out, then we change our answer, or else we not. So this condition will only done if our length is greater than or equal to n, which we want to do. If our length is not equal to or greater than n, then we have to now still again fill our length array. So what we'll do is, so because we have filled till I index, so this will tell us what is the length of our AI index which we have filled. So because we have filled 0, so it initializes with 0, so it means we have doesn't fill any number in our vector at this point, but now we want to fill. So at what number we want to start filling, so we want to start filling with this current value, so this current value, and at what point we have to go, so we have to go till m, which I've told you, and j plus plus. So we will push in our vector this j, and then we'll again do a DFS of I plus 1 because we have pushed one value in v, and our current will be this j now because we have filled this at this j, and because now we have to come back from this DFS because we now have to pop another element, we have to pop out this current element and have to pop into new element. So we dot pop back. So that's the code. Let's try to run it for some examples. That's the third question. It's a little bit tricky. We're just doing brute force approach. Okay, it's not working. So what we have done, we have made vector 0 to I, v of p of I minus v of a of I, if that's equal to c of I, value plus equal to d of I. and return value. Okay, then we are doing a DFS call of I current greater than or equal to max half. Okay, then we have also have to like return from this, because if we don't return, how will this DFS terminate? Because we have now find out some value. Yeah, it's giving correct answer. Let's submit it. So it's also accepted. I hope you understand all the three questions. If you still have any doubts, please mention down. Thank you for watching this video, and I'll see you in the next one. Bye.